All right, it's just flipped over 1 o'clock. Hello, everyone. My name is Matt Delacruz, General Manager for RAECO Rents. I'd like to welcome everyone attending our webinar on Introduction to Monitoring Chemical Sterilants. Our presenters today are Dr. Richard Warburton, CTO and General Counsel at ChemDAQ, and also Matt Chittister, Director of Technical Sales, also at ChemDAQ. In this 45-minute webinar, you'll cover the following: discuss the long-term exposure risks associated with chemical use for sterilization, recognize the importance of measuring low temperature and liquid chemical sterilants, explain the challenges related to low temperature sterilization process and equipment, identify the regulations and legal requirements for chemical sterilant use, and introduce portable monitors that address exposure concerns and prevalent future problems. And Matt, thank you for sharing the time and your technical expertise. Welcome.
Thanks for having us. My name is Matt Chittister. I am, as Matt said, the Director of Technical Sales at ChemDAQ. First, I'd like to say thank you to RAECO Rents for putting on this webinar and inviting us to be a part of it. I'd also like to thank all of you for joining us today and taking this information seriously and being concerned about the environments that you're working in. ChemDAQ, just to give you a quick little info on us, we manufacture and sell gas detection systems, and our goal is to ensure worker safety. And I think what's really interesting about us for this presentation and this webinar is we typically focus on, certain industries when we do these, but in this instance, because of RAECO Rents and our relationship with them, we're actually in multiple industries just like they are. So we're trying to present for everyone to be aware in multiple industries, because what's so interesting about these biocides that we're going to talk about today is that they're used in so many different industries. They're used in kind of different ways, but they're used for the same thing. So if you're not familiar with the biocide, and I believe that, we use the word sterilant sometimes, that's more common to the medical field. But at the end of the day, these sterilants are biocides. And what a biocide is, and it depends who you're asking, but if you ask European legislation, they call it a chemical substance or microorganism intended to destroy, deter, render harmless, or exert a controlling effect on any harmful organism. The EPA, the U.S. Environmental Protection Agency, their definition is a diverse group of poisonous substances, including preservatives, insecticides, disinfectants, and pesticides used for the control of organisms that are harmful to human or animal health or that cause damage to natural or manufactured products. So our goal today, here's the objectives. I just wanted to go over what the biocides were and how they're in multiple industries, and I'll expand on that in a minute. But our objectives today are to discuss the importance of monitoring these biocides in all industries, describe the long-term exposure risks associated with these biocides, explain the challenges related to low-temperature sterilizers and manufacturing equipment, industrial manufacturing, food and beverage industry, and then at the end, explore the legal requirements related to use these biocides safely and lawfully. We're kind of featuring, there's a lot of biocides out there. The three that ChemDAQ focuses on, and three that we find to be very important to monitor and that we find in many industries are hydrogen peroxide, ethylene oxide, and parasitic acid. And just to tell you a little bit about each one, hydrogen peroxide, everybody's familiar, or most people are familiar with hydrogen peroxide because everybody's got that brown bottle at their house. Well, that brown bottle of hydrogen peroxide is only a 3% concentration of the actual hydrogen peroxide. The concentrations we're dealing with in other industries are anywhere from 30% to 90%. And just to give you an idea of that higher end, 90%, anywhere from 85, I believe, to 93% hydrogen peroxide concentration is what is actually used in rocket fuel for air shuttles, for weaponry. But again, that's how dangerous this stuff is. It's actually propellant. Now, the great thing about hydrogen peroxide is it breaks down water and oxygen, and once it has completely broken down, there's no issue. However, many people are working around this, and it is a known animal carcinogen that people are using and they're breathing in, so it kind of is an issue until it has completely broken down. Another one, as I mentioned, was peracetic acid. Peracetic acid is used again in hospitals and industry, and it's actually a organic peroxy acid that forms an equilibrium mixture with hydrogen peroxide and acetic acid. So hydrogen peroxide is actually present in the peracetic acid as well. It's a strong antioxidant, and it's very reactive, and that's what makes it such a great biocide. Ethylene oxide, you're not going to find as much in industrial, but you're going to find it more in hospital and sterilization facilities, so just healthcare in general. But it's a surface disinfectant, and it's colorless and flammable, and it's a known human carcinogen. It can also lead to reproductive and neurological hazards. So those are the three we're going to focus on today. But again, the stress is that if you're using another biocide, you should be monitoring for that as well. And it's really always comes down to safety, worker safety, employee safety, your safety, and making sure people know their environment. So again, here are the industries that we're talking about. Hospital, there's several different industries. They're still processing. The people who are reprocessing equipment to be used in surgeries or other places in the hospital, the endoscopy or GI lab, reprocessing those endoscopes. Environmental services might use hydrogen peroxide or peracetic acid to fog a room or for other cleaning reasons. And pharmacy compounding, same thing. They're going to be using it for cleaning surfaces after compounding. In food and beverage, again, you're not going to find the ethylene oxide as much, but you're going to find hydrogen peroxide and peracetic acid. And that's going to be in protein processing plants. So anywhere from chicken, poultry, beef, pork, peracetic acid is very common. And then you'll also find it in aseptic packaging. So in order to put the liquid in and keep it clean and no organisms getting into the packaging material, you're going to use these chemicals to make it safe for storage and for shipping. And then sterilization facilities, this is more ethylene oxide. So 50% of the medical equipment in the world is sterilized and shipped out to be used using ethylene oxide. And then the last one I have here is wastewater plants. And again, that's not as common, but it's becoming more common because of some of the issues with chlorine. So all of these, there's other industries out there as well. There's always emerging markets where people are looking into using these chemicals, but those are kind of some of the big ones. So we're kind of talking about 10 reasons why to monitor, and here's reason number one. So biocides are highly toxic. Again, these biocides are designed to kill all life. They're anything that would be dangerous, whether it's food for you to eat or medical equipment for you that's going to go in your body. You want to kill all bacteria so that it's safe to either eat or be used that way. So if they were not toxic, they would not be effective. People often ask, well, if these are so bad, why don't we use something else? Well, again, if you stop using this one, you're just going to replace it with another one that's doing the same thing. And that we've seen that happen over the years. Ethylene oxide was not even realized to be as harmful as it is. It was actually developed in the late 1800s, and it started to get more wide use in the mid 1900s. And it wasn't until the 1980s that they really realized how dangerous it was, and they OSHA put in a regulation to minimize people's exposure to it. So what will happen is once you realize something like that is dangerous, they might say, okay, let's take that away. Let's start, let's move to hydrogen peroxide. But the realistic thing is hydrogen peroxide has some drawbacks as well. So again, they're all, if they weren't toxic, they wouldn't be effective, and therefore they all do the same thing. There's as I talked a little bit about the chemicals, but there's, just to break them down, there's two types. There's oxidizing agents, which that's what hydrogen peroxide and peracetic acid do. These destroy the cell walls. And then there's the alkylating agent, and that's ethylene oxide. So this binds to the proteins and the DNA within the cell and prevents them from functioning. So that's how the two work. Both agents, again, they pose a serious health risk to anybody exposed to them. High concentrations and small leaks can have a significant impact on health, especially if you're continuously exposed to those amounts, whether they are small or high. Let me move on. Number two, continuing on with this, biocides pose serious health risks if exposed. There's no such thing as a harmless biocide. As I said, they're all toxic and they're there to serve a purpose. There's really not any way around it. Again, our philosophy is to use them as safely as possible and be aware of your environment. Unfortunately, it seems that there's less emphasis placed on worker safety. In hospitals, the number one focus tends to be patient safety. In food and beverage, it's kind of about the end user and the product. So product safety and making sure that it's safe to eat or drink for the consumer. And sterilization, it's making sure that the equipment is safe to be used in the hospitals or other areas. And in wastewater, it's important to clean the water. So again, people are drinking the safe water. So it's always about the end user. And people often forget that in all these industries, there's all sorts of workers who are making it safe for the end user to use. But people aren't as worried about the worker. They forget about the worker. And then on top of that, sometimes workers will have symptoms and they're often overlooked. It might be an eye irritation or an issue in their nose or a sore throat. And often what happens is the workers, not being as informed or educated about the risks, they believe that they just have a cold or a sickness. And they kind of overlook it and they don't mention it to anyone. Little do they know they actually have those symptoms because they're exposed to these chemicals. The other thing you'll find is workers typically don't like to complain. In certain industries more than others. They don't want to be viewed as the person who's always complaining or making an excuse to work. And in some cases, it's even more serious. They just don't want anybody kind of paying attention to who they are or what they're doing, so they just keep it to themselves. So unfortunately, when things are not communicated to management or to upper management or to government, everybody just continues on with their daily tasks without realizing that there's an issue. And the last thing is biocides affect everyone a little bit differently. I know I was with 3 coworkers and there was an issue one day and I was having some major symptoms of being exposed to some peracetic acid. And I had some other people that were with me that I had go over and see what they thought about it. And again, most of these biocides you can't even smell. Peracetic acid you can smell, but I'll get into the issues with that a little bit later. But the people that were with me, they didn't really notice any issues. They didn't really smell anything. They had no irritations. And as I complained, they kind of thought I was making it up. And again, that goes back to why workers don't complain, because sometimes people think you're just making it up or looking for an excuse. I had to go outside and sit outside for about 25 minutes. I was having trouble breathing. And the people I was with did not have those issues. So now it does turn out that I was exposed to some peracetic acid. But again, it affected me differently than it affects them. So some people might be exposed to it, but they don't even know because they're not as sensitive to it. Okay, let me move on to number 3. So again, this is crossing industries, which we don't typically do, but we're doing it. Sterilizers and reprocessors, so typically on the healthcare side, as in manufacturing industrial equipment, so the food and beverage side, the protein side, the sterilization company side, their equipment in all of these industries, it can and does malfunction. You know, there's a lot of assumptions out there, here it is, of safety. Hey, you know, this big company made this product and they send us an SDS and they say that it can't leak and it doesn't have issues. So people just tend to go with that and never realize that things happen. I often, you know, remind people that, you know, every great product has issues. It happens. There's nothing you can do to make every single thing perfect all the time. So the assumption that your equipment is always functioning properly, how do you really know that? And as time goes on, there's wearable products, you know, wearable items that make up these products that they're going to deteriorate over time. So what I always like to say is an analogy. Would you, if you're taking a road trip from the East Coast to the West Coast, would you feel more comfortable taking the brand new car or taking the car that has 200,000 miles on it? You know, obviously, you're going to feel better with the new car because that car with 200,000 miles on it, it's been through some wear and tear, and it might have some issues that you're not even aware of. And halfway through your trip, it might break down. So that's what we're saying about equipment in general and sterilizers in general. Yes, things are made very well. It's no knock on any company or product. We do believe that people make really high quality products, but at the end of the day, as things go on and they get older, they break or they just have a malfunction, and there's nothing you can do to prepare for those moments if you don't have monitors to know that it's happening. We've also heard stories in the healthcare side, and won't name out any specific locations, but you know, somebody had passed out, somebody had inhaled some peracetic acid, and they were actually unconscious on the floor, and they had to be pulled out from the facility. And this facility did not have monitoring. So had somebody not happened, you know, just by chance walked into that room, that person would have been laying on the floor continually exposed to those gases, and nobody would have known it. So luckily, somebody had walked in and they were able to get the person out, and in short term, they were okay. And again, I don't tell this story to scare people. You know, we don't think that this is happening every single day, everywhere you go. Again, I think the issue is what happens when it does happen. Are you prepared for it when it happens? Again, in this case, they were very lucky because somebody walked in, but if they weren't that lucky for somebody to walk in, how would you know? Now, if they had a monitor, there would have been alarms going off all over the place, and somebody would have known to run in and help that person, probably sooner than they actually found that person. And we hear about it all the time in the industrial side too. Not necessarily to the point of people passing out or being unconscious, but employees going to complain about feeling that they were exposed to something. And by the time somebody gets down to that area, or you get some sort of, you know, on-the-spot test that you can use, or you bring in an industrial hygienist, it's too late. That issue may no longer be there. And you don't know whether that person was accurate or not when they said that they were exposed. But again, if you had monitoring in place, you would know that level as that person was feeling those symptoms. You could actually walk down to the floor and say, hey, we are noticing some readings on the monitors. How you feeling down here? What's going on? So again, it's not, we're not saying that every single day that there's issues everywhere. We're saying that there are issues places, and you really just need to know your environment and be aware of what's going on. And in the case of a major leak, be able to respond to it proactively rather than reacting. And let me move on here. So one of the things, again, that we were talking about here is smell Smell, you might smell it. Well, smell is not a reliable method of detection. And here's why. Most biocides have little or no smell. As I said before, hydrogen peroxide, ethylene oxide, no smell. Peracetic acid does have a smell. But again, even with the smell, my nose and your nose are different. So if you smell it to a certain point and I don't smell it, as my example earlier with me, you can't gauge who's accurate or who's not, or, oh, that smells like a 0.5 ppm, or that smells like a 1.5 ppm. All you know is you smell something. So even if you could smell these biocides, that doesn't mean you know what the level is. The other factor you get into is olfactory fatigue. So olfactory fatigue would be you're working in that atmosphere all the time and you're slowly exposed to some of these smells. And after a while doing it, you don't even really notice the smell anymore. It just becomes normal to you. So who's had that where somebody's walked in your house or gotten in your car and said, hey, what's that smell? And you're like, I don't even know what you're talking about. I don't smell anything. That's because that's olfactory fatigue happening to you. You're getting in there all the time and you don't even realize it anymore. So again, and then as this last point says, noses aren't good gauges. So as I said, I can't sniff something and tell you what the level is. The only way to know that true level is to monitor it, right? So again, smell is not going to help you figure out what your environment is or if you're having any problems. Number 5, employers have a legal duty to provide a safe working environment. So in 1970, there was the OSHA Act. It created a legal duty for employers to provide a safe work environment and a legal duty for employees to follow all workplace standards. Now, this act was very important. It created 2 separate arms. One was NIOSH and one was OSHA. Hopefully, I would imagine most people are familiar with these, but I will talk about these guys for a second. So they were founded in this OSHA Act to work hand in hand together. NIOSH, the National Institute for Occupational Safety and Health, was supposed to do the research and make recommendations to OSHA on what levels and what regulations should be put into place. OSHA, the Occupational Safety and Health Administration, was supposed to develop and enforce these standards. Now, the interesting part is most of the standards that they developed were adopted from 1968, the ACJIH. So that's, I'm not sure how many people are familiar with that, but that's the American Conference of Governmental Industrial Hygienists. Okay, so now let me just flip back to them. They were founded in 1938, and their goal was to protect workplace employees through the development of science-based occupational exposure guidelines. And they established these TLVs, or threshold limit values for chemical substances. Now, when OSHA Act happened and they created NIOSH and OSHA, they had all these chemicals that they needed to have regulations for. But they didn't really have the time or the ability on their own to create all that. So they basically adopted most of their regulations from the ACJIH conference that happened in 1968. And the scary thing, I think, or maybe scary is not the best word, but the unfortunate thing, whatever you want to call it, is a lot of those regulations have not been changed since they were originally developed. So here we are, 50 years later, and we're still using information from way back when. So these all work hand in hand. And most of these biocides have regulations. Most of them are built over an 8-hour time weighted average. So what is that? What is your exposure limit to those chemicals over 8 hours? So it's going to be 8-hour average. So if for an hour you're exposed to 2.0 and then an hour you're exposed to 0, obviously over that time frame you're averaging out to 1.0. But they look at that average over 8 hours. So ethylene oxide and hydrogen peroxide, they have a 1.0 parts per million regulation over 8 hours. So if you take an 8-hour sample, what is your exposure to those chemicals? Now, peracetic acid, being a slightly newer, or not slightly newer, much newer, but it's a much newer used biocide and has less research on it. There's actually no current OSHA regulation. Now, there are some other regulations out there, such as ACGIH, which uses a 0.4 over 8 hours. And what's really interesting about this is under the general duty clause, it doesn't matter if OSHA has a standard in place or not. If OSHA, if there's a recognized standard out there that is considered to be legitimate, and an ACGIH standard is such, and your employee would complain of having an issue that they believe that they're being exposed, that would be enough under the general duty clause for you to have some issues with OSHA, right? So you know that there's a recognized standard, somebody's brought it to your attention, and yet nothing has been done to remedy the situation. So you could actually be fined by OSHA for a matter like that. Richard, do you want to talk about any of the OSHA stuff or general duty clause while you're on here?
No, I think you covered it very, very well, Matt.
Okay, all right. I think the other thing that's interesting is a lot of these, especially ethylene oxide, but the OSHA 29 general duty clause requires employers to retain exposure data. So again, by monitoring and knowing your environment, you can also store that information and keep it. And we'll get into that a little bit later as well when we talk about some of the legal ramifications. Let's see. Let's move on. So, and just to make a quick point here, this all for one here, whether it's hospitals, steel mills, water treatment plants, OSHA can oversee all of those places. And yes, there's OSHA, that's a lot for OSHA to cover, but all it takes is one employee to call and say that they're having an issue, and that's going to bring them in to check you out, right? So they're going to, all it takes is one person to fear that somebody's not paying attention to them or doesn't care about the environment they're working in. And if they make that phone call, OSHA is going to come and see what they can find out. So you might as well not only protect your employees' health, but protect yourself and the company that you work for. I will also mention too, some of the other standards that are out there. 8 hours the most common. There's also a 15-minute time-weighted average that is included in some, and then so that's going to be their average exposure over a 15-minute time frame. And there is also an IDLH, which is immediately dangerous to life and health. So that's just a flat out, basically, how high can it be that you're exposed to, and it doesn't take a lot of time to be exposed to it before it's really going to cause damage. And they typically look at that over a 30-minute window, but it could happen even sooner than that.
Yeah, hi Matt. I'd just like to jump in if I can.
Yes, please.
The IDLH is the limit where after 30 minutes of exposure, it either cause some permanent damage, or else the person will be inhibited such that they can't get out of a location. So if you get something like hydrogen peroxide, which is a severe irritant, even though at the IDLH they may not suffer serious damage, they will have so much irritation that they would be unable to find their way out. So the other thing I was going to add is a lot, sort of reinforcing what you just said. In addition to the OSHA laws, a lot of states also have their own permissible exposure limits. So, for example, with hydroperoxide, there's the OSHA permissible exposure limit of 1 ppm over 8 hours. But there are a couple of states like Washington and Hawaii have short-term exposure limits of 3 ppm. And so, in those states, then the employer has to follow both the state and the federal regulations.
Right, and thank you for pointing that out and giving me a minute to take a little drink break over here. To Richard's point, and to what I'm saying here is there's really 3 levels typically you can look at, and even peracetic acid, which doesn't have OSHA recommendations or regulations yet, it still has a 0.4, and correct me if I'm wrong, Richard, but 0.4 over. And that's actually over 15 minutes. I think I said 8 hours before. It's 0.2 over 8 hours. And it's 0.4 over 15 minutes, correct?
Yeah, the ACGIH is 0.4 over 15 minutes. It's a STEL TLV.
Right.
So at the moment, there isn't an OSHA PEL for peracetic acid. Cal OSHA has proposed 0.2 for the 8 hour. Right.
So again, we're working with something that, you know, it doesn't have an IDLH. They've thrown out an IDLH value in the past, which was roughly 5 years ago, and nobody could really agree on it. So again, you're dealing with you know, things that are changing, people who disagree on what the level should be, and then again, you're basing on 3 different levels. So the instantaneous, a 15-minute STEL or short-term exposure limit, and then an 8-hour permissible exposure limit, or and what happens is, again, how would you know all these levels that your employees are exposed to? You might know that at a given moment it seems like they're having an issue, but you don't know what's caused that. Was it a really high, quick burst that they were exposed to of the gas? Was it 15 minutes that they were exposed to? Was it 8 hours that their whole shift they were exposed to? So again, with chemical monitoring, you can have sensors and you can have output and displays that let you know all 3 of those at the same time. So again, not only does OSHA provide some guidance for you, but you know, how would you figure out these levels if you didn't have chemical monitoring? Okay, and then I'll move to number 6. So I kind of covered number 6. Number 5 and number 6 go together, but this is where we talk about they have the same or that occupational exposure limits actually exist. So again, most of this was developed by the American Conference of Governmental Industrial Hygienists and their TLVs back in 1968. OSHA, again, is the ones that can prosecute in the U.S. and they kind of enforce things. Yes, OSHA is overwhelmed and they're kind of all over the place with trying to enforce all their rules in different industries. But again, all it takes is one employee to make a phone call. The permissible exposure limit is the legal standard for the maximum exposure that an employee may receive. And again, that could be a 15-minute or an 8-hour, or it could be both. And then I have feeling overwhelmed, oh my. There's a lot to take in. There's a lot of, to Richard's point, there's Cal OSHA is recommending some standardization for and regulation for peracetic acid. So is that federal OSHA? No, but it's Cal OSHA, and that's a recommended, or that's what's the word I'm looking for? It's a Richard.
The Cal OSHA is the law in California, but federal OSHA also recognized it as a recognized standard. So federal OSHA could use the Cal OSHA limits if they were going to prosecute someone under the general duty clause.
Thank you. So it's a recognized standard, correct? It's kind of
yes.
Yeah. So I mean, that's important to know. And again, there's so many chemicals out there, and I'm sure each one of you has used or is using several different ones at any given time. And most likely they have some OSHA guidelines and regulations, and it's a lot to be aware of, and it's a lot to be aware of if you have to know what other recognized standards are saying as well. So we get it. It's definitely an overwhelming feeling. Number 7, OSHA requires safety measures for employees. So again, education. SDS sheets, putting into place an emergency plan. There's all this information. If you're going to be working around certain chemicals, you need to know what you're working around and how you handle it and how you deal with it if there's an exposure or a leak. Again, how do you know unless you have monitoring? How do you know? You just don't know. So, one of the ways people try to do it is a badge or, a spot check every 3 months or once a year. So somebody comes in, an industrial hygienist comes in, or you just do it on your own, and you take a sample of what's going on in that environment. The problem is that you're not going to get that information back until a week and a half later. So how do you know, yes, now you know that you might have been exposed to something, but it's too late. You've already been exposed to it. I mean, don't you want to know before it happens? So again, one of the analogies I always use is, I have fire alarms or fire detectors all around my house. If you didn't have a fire detector and you use some test to find out later, it would be too late. And the same goes for, why you should have a carbon monoxide detector in your house and possibly some other things. So the difference between badging and doing industrial tests once every 6 months or a year, I mean, yes, we want to give credit to people that they're trying to be aware of the environment, but it's just not an accurate picture. The only way to have an accurate picture of your environment is to know what's going on all the time. And, you're going to focus on areas where obviously there's possible leaks, but you're also going to look at anywhere where employees might be working to make sure they're safe. All right, number 8, sorry. We want to mitigate the risk of litigation. So again, OSHA's out there enforcing laws. In the last 10 years, OSHA's visited 1,700 roughly of 5,700 medical and surgical hospitals. And, so on average, they can be inspected every 33 years. But realistically, when employees complain, they're going to get there more often. And that's the same way industrial is, right? So yes, they can only see you once every, multiple years because they're overwhelmed. But as I said before, it only takes one phone call. If OSHA does discover noncompliance during a visit, they may issue warnings or fines, depending on the magnitude of the infraction. And each violation cannot be more than $70,000 for each violation, but not less than $5,000. So you're looking at $5,000 to $70,000 just in fines. Well, again, you can have continuous monitoring that is cheaper than that, right? So you're saving yourself, and that would just be for one fine. What if there's multiple fines, or what if there's increased penalties as they find more violations? So the penalty for a serious violation is on average $13,500 a violation, but it's going to go up with each willful violation.
Yeah, and of course, if OSHA goes into a plant based on the complaint, once they're in there, they can look at all the other processes going on in that plant too.
That's a great point. So now not only is it the chemical exposure, but that there's some other work practice that's not being done correctly. So then you could be looking at more fines.
Yeah, we had one customer. Sorry, we had one customer where OSHA came in because of employee complaints about dust in the air, and then going through the plant and ended up asking for all their records about PAA exposure.
Right.
So OSHA will do that.
And then what you can do is you can reduce the risk of injury to the employee. Review the workplace for safety and compliance. Develop a written safety plan. ensure that necessary equipment is available, employees have been trained to use it, and then perform regular inspections. Okay, number 9, reduce lost time from work. Again, one very difficult thing is when people are sick or people have to take off, especially if they're, it was caused by that environment, by where they're working. So lost work days equals higher turnover costs and higher worker compensation rates. And according to the Bureau of Labor Statistics, in 2008, there were 512,000 injuries and 32,700 illnesses in healthcare and social assistance industries of 310 per 10,000 full-time workers. So again, this is more focused on healthcare, but the point is there's injuries and illnesses numerous every year, and these costs add up. So if you can find a way to minimize those lost days, then you're only helping, your own costs, the company's own costs. You're also, physical and physical illnesses and injury and missing work can cause, emotional and financial security issues and fears. So it just kind of builds on top of the actual physical. And then go ahead, Richard.
Yeah, one thing that we found when we first introduced our peracetic acid monitor, at the time, this was before the ACGIH cell TLV for PAA, and so a lot of places like aseptic filling lines, they were only monitoring for hydrogen peroxide and acetic acid, and there are at least a couple of plants where their workers were complaining about sore eyes, nosebleeds, and other signs of irritation, but the hydrogen peroxide and acetic acid levels, when they were checked, they were fine. And this led to a lot of distrust by the workers of the management, because the workers knew that something was not right. And once we were able to put in PAA monitoring, they could say, "Oh, my nose is hurting, and the PAA monitor is showing a reading." Now, and that helped the industrial relations a great deal.
Right. Yeah, that's a great point. I mean, just as a side note, our peracetic acid sensor and system is specific to peracetic acid. So we have a patent pending filter that eliminates the hydrogen peroxide that's there, and you only get the peracetic acid. It's really accurate to what's going on with the peracetic acid. All right, and then let me get to number 10. So again, show your employees their value. I think this is just really important. I mean, one of the greatest challenges we all face is employee turnover. Just so much time and costs to train somebody new, and especially when you lose somebody who's really good at their job. So you want to keep people and make them better and better and keep them for as long as possible. And if people don't feel that they're safe, they're less likely to be efficient and effective. They're standing there and they're worried about what's going on, or they're negative in their head to say, "Hey, I don't even feel like doing this because I'm being exposed and nobody even cares." So, there's a lot to be said about taking care of your employee, and it's not always just monetarily. It's letting them know you care about them, letting them know you care about their safety. And, by putting monitors in place, they can be reassured that you care about them. And we hope the readings are zero. We really do, or low. But we're also realistic to understand that there's going to be spikes in the readings. There's going to be leaks. There's going to be exposure. And if you're aware of it, you can create a safe atmosphere and you can work around it. And if you can make an employee feel value, again, they're going to work harder. They're going to be more efficient, and typically, they're going to be your high performers. And you have a nice little relationship there. So, in review, the 10 reasons why to monitor. Again, the biocides are highly toxic. They pose serious health risks if exposed. Equipment in general can and will malfunction. Smell is an unreliable method for detection. Employers have a legal duty to provide safe work environments. There are occupational exposure limits, and they are working on new ones. Sometimes it's a little slow, but they're working on it. OSHA requires safety measures for your employees. It'll help you mitigate the risk of litigation. It'll help you reduce lost time from work, and it'll show employees their value. And I just want to say thank you for tuning in and being a part of it, and I'll pass it back over to Matt.
If anybody has any questions, there's the chat tool. You can go ahead and ask some questions for us. I'd like to thank Matt for the presentation. And if there are any other questions, you can always call us at 866-RENT-THS or email me at matt@raecorents.com. All right. If you need to know any more about our technologies we supply, please follow us on social media. We put out technical tips on my blog at blog.raecorents.com, and you can follow us on LinkedIn and Twitter. We record all these sessions, which will be up on YouTube in the next day or two. And if there's any topics you'd like us to cover in our webinars, please email me again at matt@raecorents.com. We have access to lots of products and process specialists, so feel free to ask. So we do have a question. There's a question here. Do you know of any hazards associated with HOCl?
Richard?
Okay. HOCl, that's a hydrochloric acid. This is the active ingredient in bleach. And so from a breathing perspective, that the main hazards are the hazards of inhaling chlorine. And chlorine has an OSHA PEL. I think it's 1 ppm, but I don't have the number in front of me. In addition, of course, you also have the problems of irritation to the eyes, respiratory system, skin contact, eye contact, and so forth.
Okay. Another question here is, what's the appropriate PPE for workers using electrostatic sprayers to disinfect buses, subways, and other work environments? Do you have any recommendations?
Richard, go.
I think I would base the PPE based on whatever chemicals it is that they are spraying. I'm not actually familiar with that kind of spray technology, but whatever it is that they're spraying, I would try to choose PPE that is appropriate to the chemical that they're using. And so that information should be available on the safety data sheet.
Okay. Again, another one here. Is there any specific law related to ETO?
There is an OSHA standard for ETO. It's 29 CFR 1910-1047. The laws, in general, that covers a lot of similar ground to the hazard communication standard, which is the general rule for working with chemicals in the workplace. But it also has some additional requirements that are specific to ethylene oxide.
Okay. Do you guys want to talk a little bit about the monitors you have for monitoring these compounds? I didn't really get into too much of those.
Yeah, sure. I mean, I'll talk about that. I mean, our number one focus is always safety, and just to let people know that they should be monitoring. What we provide is real-time monitors. So we have a fixed monitor. We actually have two types of fixed monitors, and we have a portable monitor. And we're working on a specific to industrial monitor. And at the center of all of these monitors and systems is our sensor. So we have a sensor that, we have 3 different sensors that we focus on, and those are the 3 gases we talked about today. The ethylene oxide has a patented chemical filter on it to filter out other interference. So a lot of times these chemicals, you can be set up to read for one chemical, but another chemical that's very similar to it will cause the sensor to go off. So with ethylene oxide, there's some alcohols or carbon monoxide that can cause some cross sensitivity. So we have a filter that's built into that sensor to filter the carbon monoxide and the alcohols out, so you only get a reading of the ETO. The peracetic acid sensor has a filter on it to eliminate the hydrogen peroxide off of it, so you don't get that into the reading, and you only get a true reading of the peracetic acid. And the way our sensors work is it's a yearly service is typically how people do it. And the great part about that is it gives you a peace of mind. So in order to make sure that these sensors are working correctly and that they're accurate, you want to make sure they're calibrated, and you want to replace these filters. So 3 times a year, roughly every 4 months, we're going to send you a sensor with it's going to be calibrated. We know that it's accurate. The filter is replaced. We're going to ship it to you with a calibration certificate, and you'll know how long that's good for. And you're going to put that, you're going to connect that to the hardware you have, and you're going to take the old sensor and put it into a box and just ship it right back to us. And that shipping back and forth is covered under the program. So that's kind of how the sensors work. And again, they're paired. So that's the base of the system, and then it's paired to however you want to see the data. So there's a portable one that we use, an Android software. It's an Android app. It's brand new. You can choose between a handheld size that you can put into your pocket or put onto a belt clip, or there's a tablet, and it runs a Safe Side app on it, it's called. And it works mainly through Bluetooth. That's really the most effective way. You could hardwire it, but you can actually have the sensor connected to the tablet by Bluetooth, and you can either walk around and spot check holding the sensor in your hand. You can clip the sensor to your collar. You can put the sensor in a specific area and just leave it for a while, and as long as you're within Bluetooth range, and come back and check it. And we're also working on a personal monitoring adapter where it'll pull the air in, and that sensor will sit on your hip, so you can get like an 8-hour shift read of what somebody's personally exposed to. So we're working on that. That should be out later in the year. But the actual new portable Android tablet is available now. And then with the fixed monitors, so this is, you really want to understand your environment, 24/7. So it's called the SteriTrack 2 or 2 Plus, and they're going to display, the current gas reading, the 15-minute time weighted average, and the 8-hour time weighted average. And then if it's the SteriTrack 2, it's kind of built to relay that message back to a computer, a central computer. So maybe you have 4 points that you're worried about, so you want 4 sensors. So you'd have 4 SteriTrack 2s, and they would all wire back to a main computer that could sit in a manager's office, and they could see what's going on at all 4 locations at the same time. If you don't like the wires, or you don't want to need that central hub, you can go with the 2 Plus, which you could still have 4 of those 2 Pluses, let's say, but instead of sending the message back, the data back, it's internally stored on the monitor itself locally. So you can go with a flash drive and take that information off when you need it. And then we're also working on, and we hope will be out hopefully in the fall here, is an industrial system that is basically the SteriTrack 2, but it protects it's a stainless steel unit that protects the sensor from the wet environments that typically happens in the protein processing plants and the food and beverage. So it protects it, and it also gives you a more accurate reading because it's pulling the sample into the sensor and not exposing it to the atmosphere, outside on the outside there. Richard, do you have any comments on any of the products? No, I guess not.
So
So,
there was another question. There was another question out here of, can you monitor hydrogen peroxide and PAA using one direct read meter?
so no. Now, I'd be curious to understand their use. We will get, because hydrogen peroxide helps to make peracetic acid, we will get a lot of people that ask us that they want to monitor both. But I can actually send this person information too. We find that based on Richard's research that peracetic acid is the more harmful of the two. It also has the lower regulations, right? Like it's a 0.4 over 8 hours and 0.2 over, 0.4 over 15 minutes and 0.2 over 8 hours. And basically, if you're using our peracetic acid sensor and you're worried about the hydrogen peroxide in there, don't, because if the peracetic acid is below levels, the hydrogen peroxide is going to be below levels as well. Richard, did you want to expand on that?
Yeah, I think the philosophy there is that we should go and detect the most hazardous chemical, and so that is a combination of the toxicity of the chemical and its expected concentration in the air as a vapor. And in most applications where peracetic acid is used, peracetic acid is far more hazardous than the hydrogen peroxide. So if we monitor for the peracetic acid, then we know that the hydrogen peroxide will be okay. So usually just monitoring for the most hazardous chemical is sufficient.
Right, but and to expand on that, if they are looking for two separate uses, the portable or the SteriLant 2 fixed are built to match 1-to-1. So if for whatever reason they're in the same facility, but they have peracetic acid in one area and hydrogen peroxide in the other, then you would need two different sensors, and preferably two pieces of hardware. But if you had the portable safe side tablet, you could switch back and forth and connect to either sensor as needed, if that makes sense with the Bluetooth. So you could read hydrogen peroxide over here and then disconnect and reconnect to the peracetic acid sensor. That may become a little bit cumbersome, but it would work.
Yeah, and the same is true for the SteriLant 2s as well.
Yeah, that's true.
If you had a change in the process and you say it was an aseptic filling line and you were going from you update your equipment from peracetic acid to hydrogen peroxide, you just change sensors over.
Right. So you just contact ChemDAQ, let us know, or if it's only one use, and if you're using both, yes, you just do the same thing. You just switch sensors.
Okay, that's good. I don't have any other further questions here. So at this point, thanks for the presentation. We will conclude and thank everybody for attending.
Thanks for having us.
All right.
Yeah, thanks for having us.